So from the sun, you've got Mercury, Venus, Earth, Mars, which is always in the news, Jupiter, Saturn, Uranus, Neptune, and then it's not on here because some people have said it's no longer a planet, might be a dwarf planet, but that's Pluto. So those are the 9, but now 8 planets in our solar system and how they line up. So when the planets are in alignment, several planets gather closely on one side of the sun at the same time. So that's why we're talking about this, because this is in the news right now. A planetary parade would describe when several planets are present in the sky in one night, not necessarily close to the sun. So you can see the model right now that we're going to show you, and you can see where the sun is, and you see all of the planets except for Mercury is on one side of the sun. So that means it would look in the night sky kind of like this, which was taken the other night. So from the northern hemisphere, and you can see the lights of a city are down below. In order to see the planets, you need to be in an area that doesn't have a lot of artificial light. So the darker the area is, the easier it is to see stars and planets on nights like what's going on right now. So that you can see that we can see Mars, Jupiter, Uranus, Neptune, Venus, and Saturn. They are all in the night sky right now, and they'll remain in the night sky for the next month. And then around a month from now, during the end of February, that's when we're going to see the other planet, Mercury, come around from the other side of the sun, and that's where it will be. So when you look up in the sky and you go, is that a star or is that a planet? Well, if it twinkles, remember the song Twinkle, Twinkle, Little Star? Well, stars twinkle, planets don't, okay? So you can take a look at the brightness, and it's pretty easy to see, especially if you have some binoculars or a telescope, or if you're someplace that doesn't have a lot of artificial light around you. It's going to be easy to see the brightness of a planet as opposed to a star. We're talking about the planets are aligned where you can see a lot of them. Right now you can see 6 of them in the night sky because they're on the same ecliptic, the path of the sun, when you are looking up in the same direction. So one thing you can do is you can see if the object moves, all right, stars are always going to be in the same spot, which is why you can see constellations when you look at the same area of the night sky at different times. Planets will be moving, so that is another big difference also. So as of right now, there are currently 6 planets aligned in our sky. We talked about that, saw the model. Then at the end of February, the other planet will join it. Mercury will be there, and that is when you'll be able to take a look at the model, and then you can see the model right now, and you've got the other planets all over there now, except for just Pluto's up there, right? And then obviously you're not going to see Earth because you're on Earth, right? So that's the way the planets would look then. So if you wanted to see every single planet in the solar system, every 396 billion years is when that happens. Now, nobody was around the last time that happened, so it could happen sometime soon, but I'm guessing it probably won't. But anyway, that's that part. So we're talking about planets, and we can see that right here, this is the way it will look. So you've got the 3 up here, you've got the other 4 down here, so you've got the 7, everything except Earth. That's the way it will look towards the end of February when you've got that other planet, Mercury, coming around from the other side of the sun. So, planets are spheres. And instead of talking about scientific notation and all of the millions and millions of miles away that these planets are, we're going to talk about the volume of a sphere, which is we were just talking about with Samuel, the volume of a rectangular prism. Before we can go to the volume of a sphere, we need to figure out where that formula comes from. So we're going to start off with the area of a circle. So we know that the area of a circle is pi r squared because 2 pi r is the circumference. But remember, when we're doing area, we're multiplying 2 dimensions. So we've got pi r squared is the base of a circle, which is right here. So we can see the circular shape at the base of the cone. The height of a cylinder is now where we're getting into 3 dimensions. So we're taking the circle, rising it up, now we have a cylinder. That height is the 3rd dimension. So A cone is a third of the volume of a cylinder. Now, here we've got a 3D representation of a cone and a sphere. It just so happens that if the radiuses are the same, it will take 2 cones to fill 1 sphere. So that's going to come into play. So right now, with the third for the cone, we can see that it's pi r squared times the height, because we're talking in 3 dimensions now, divided by 3, because the cone is a third of the cylinder. 2 cones, as I just said, equal the volume of a sphere with the same radius. So now we've got pi r squared times 2r. Now somebody goes, where's the 2r coming from? In a cone, the radius, if you put one radius on top of the other, it's the same as the height of a cylinder. So that's where the 2r comes from, because we're going to need 2 cones to fill the sphere. So I know it seems like a lot, but hopefully you're following along. So now we're going to take the 2r out of here, and we're going to say we have 2 pi r cubed plus 2 pi r cubed, which is the 2 cones, divided by 3. All of that now leads to the formula for a sphere. So the volume for a sphere, when we put it all together, is 4/3, because we had 2/3 and 2/3 is 4/3. Pi r cubed remains the same. So if we want to figure out the volume of this sphere, and we are going to make this 4 inches, all we have to do now is substitute the 4 inches for the radius. So we have 4/3 pi r, which is 4 to the 3rd power. So we're going to leave everything the same. We have 4/3 pi. 4 to the 3rd power is the same as 4 times 4 times 4. So 4 times 4 is 16. 16 times 4 is 64. So now we have this. So now we have 4/3. We're going to convert that to a decimal, which is 1.3, or convert it to a decimal. I'm making it a fraction again. Oh, let me go down to the eraser. So we've got 1.3 repeating. Pi is 3.14. These are all being multiplied times 64. When we do all of that, that's going to come out to be 261.2 inches cubed, and that is the volume of this sphere with a 4-inch radius. That's how we take spheres, planets, turn it into volume. That's today's Math in the News.